So, good afternoon, everyone. I hope you had an amazing catamaran trip. I hope all of you are relaxed and you are waiting for the finalization of this conference for the aperitif. But before that, let's go through the topic of my presentation, of my speech, which is securing the industrial IoT ecosystem. And considering that, I will move you through the strategies from product design to the real-world operations, also focusing on some use cases which we did for our clients. And I would like to assure you that for sure, I wouldn't like to take the security of the industrial IoT ecosystem in this way, so just by disabling all of the devices. I would like to share with you some real use cases, real strategies that are currently working. Okay, and who am I? I am Rafał. I am working in EY, formerly known as an Ernst & Young company. I am engineer, I am consultant, and I am working in technology consulting. And I am from Poland, and I am located in a team which is a center for excellence, which is a global hub for OT, industrial IoT, cybersecurity, which means that we are not doing only PowerPoint slides, as in typical consulting. We are also doing implementations. We are also doing real research, product security, penetration testing, implementation of cybersecurity solutions, trainings, assessments, and many, many more. Okay, let's move to the topic. So what are the security challenges which are facing industrial IoT devices and all the infrastructure? Probably you could hear, or maybe not, or maybe you could hear about different cases, different cybersecurity events and incidents. But here we have a couple of them as an example. The first one is about supply chain risk, which was related to that Chinese vendor of solar power inverters embedded backdoor in their devices, which was Rogu communication device, which was sending the data to the vendor of this system for some kind of manipulation. The second one is about more than 35 million devices attacked by distributed denial of service attack, and target devices in this case were devices related to consumer, related to industrial, related to IoT, related to critical infrastructure, and many, many more. And the third one, IO control, it is custom malware created by one country, which was targeted against Israel and the United States IoT and operational technology infrastructure. And regarding other security challenges, we can differentiate here a couple of them, which are really, really common, I would say. The most important is lack of network security, so lack of encryption, lack of monitoring, etc. There are also a lot of constraints regarding data privacy, lack of physical security, so lack of securing, of embedding some backdoors, of allowing to make reverse engineering of the devices, supply chain risks, lack of standardization, which can create also a great path for boosting cybersecurity, some hardware limitations, which are basically not allowing to increase the specific capabilities, and lack of updates. Moving forward, we have also a well-known concept regarding IT and industrial convergence journey, which is happening more and more nowadays. It started about, let's say, 20 years ago, and currently the majority of our customers are in the connectivity focus area, which means that they are almost completed with connecting these two worlds, IT and industrial, and they are looking for the common services regarding business, regarding industrial. They are looking forward for cloud connectivity, for digitalization of their companies, for fully implementing Industry 4.0 and to be autonomous teams, which means that they are implementing and they are pushed to implement also a lot of IoT infrastructure in that environment, which will lead them for increasing and boosting this maturity regarding cybersecurity in these areas. And there is a question if product and infrastructure security can help anyhow in boosting this posture, boosting maturity, and to creating more secure environment. If we consider that product security approach can consist of 4 various pillars, for example, standards, supply chain, zero trust, and testing, we can try to elaborate on this product security approach as a pretty good standard and way of securing infrastructure and devices. So let's kick off maybe from the standards. Here we can distinguish a couple of them which are related to the industrial and are related also to the specifically IoT devices. The first one, ETSI 303645, is related to end-user consumer devices. The second one, IEC 62443, is pretty important regarding operational technology and industry cybersecurity. NIS2 standard, the middle one, is about European Union regulations, which are currently pushed towards end users and customers and companies to fulfill these requirements. And 2 last ones about security architecture for IoT devices. And what we can achieve thanks to these standards which are related to the IoT, product security and cybersecurity, for sure these standards can create a path for us which allows to fulfill specific requirements, to go also with specific needs from governments. And after fulfilling all of that, we can also certify our products, certify our infrastructure, which is a proof of our cyber resilience. And also we are better and better companies in front of the eyes of our customers. Another issue is supply chain security. I noticed that since a couple years, there are more and more attacks related to that supply chain, and also more and more of our customers are looking forward for securing this area as well. What we can notice in terms of our clients that a lot of embedded devices are delivered with some kind of backdoors, 0 days, with vulnerabilities which are then making the final product vulnerable for the specific attacks. A lot of devices are provided with default configurations, with some weak or default credentials, and some of the sub-products, which are the part of the final product, are built without security in mind. How we can address that topic? For sure, we should include suppliers as soon as possible in the requirements of RFI, RFP, etc., and then building a common offer with them. We should also do quite enormous security awareness trainings. We should also require from our suppliers these kind of things. And the answer for this could be also joint product security testing, which will create the specific needs for that testing, and the outcomes will allow vendors and suppliers to improve the security posture of their products. The third pillar regarding product security is zero trust. So if we consider that our world is pushing towards digitalization currently, which means that we are having more and more IoT devices, we are having more and more needs for remote access, more and more cloud connections, IoT gateways, etc., etc. We should move from the traditional approach of the network to the zero trust approach, which means that least privilege should be incorporated for all the users, not only for the externals. We should consider remote access as a zero trust approach. We should create visibility of devices, users, applications, and all the connections. And we should control the traffic not only from the north-south, so not only on the firewall level. We should also consider monitoring the what is going on inside of our network, so east-west communication. And the last one, part of this product security approach is testing. We can divide testing in subsequent areas. For example, first one, rigorous assessment of all the needs of products to identify possible vulnerabilities. Second one, penetration testing, which can be related to deploying ethical hacking to uncover potential security issues, vulnerabilities that can be later addressed, and also compliance with specific standards, with specific regulations, if our products are following those required areas. And the last one is hardening, which means that together with vendors, together with manufacturers, we can apply all of that changes which are resulting from product testing to our products to harden them. And testing we can divide into hardware testing, application testing, and communication testing. Regarding hardware testing, we can verify if our devices have backdoors, if they are vulnerable for reverse engineering. Regarding application testing, mostly we are looking for the vulnerabilities. And regarding communication testing, we are looking for the some kind of capabilities in terms of sniffing communication, intercepting communication, checking if communication is encrypted, or verifying if, for example, we can do man-in-the-middle attack. And now, by the end of this presentation, I would like to share one use case which we did with our customers regarding advanced metering infrastructure. And advanced metering infrastructure, these are smart meters, which probably currently all of us in European Union have in our houses. And these smart meters are measuring the amount of electricity and water used by consumers. And then this data is transferred through IoT data gateways, through the network, to the APN points, and then it goes directly to the distributors of energy or media, to the AMI network, to the middleware systems or HES and SCADA systems. And these tests we are usually conducting in 3 phases. The first phase is sensor testing. So we are testing data sources like these smart meters. This could be IoT devices, GPS also devices, and some kind of actuators. Second phase is verification of data transfer, so connectors and concentrators, edge devices. And the third phase is application and services testing, which is related to data processing, the central applications, and middleware and common services. And what could be biggest threats for advanced metering infrastructure? We are identifying 3 of them. These are local regional blackouts regarding energy and water, electricity theft and fraud, and also clients' personal data theft and reputation damage. And now I would like to show you some sample findings. So in tested smart meters from electricity, we could easily do microcontroller program dump because this data wasn't secured. Anyhow, all the microcontroller ports were not secured. They are easily accessible. and the configuration behind this microcontroller was allowing also to intercept this data. Another one is that we noticed that these devices are poorly secured regarding physical seals, physical access, so they could be easily manipulated by consumers. And also we saw that operating system bootloader was available for manipulation, and it was available after connecting a serial cable. And also we had some unprotected interfaces, and we could easily download the values from the registers. Regarding application testing, we noticed that these devices were not using secure communication. It wasn't HTTPS. We could download also debugging files without any privileges. There were also not closed or secure privilege accounts, and there were no any measures for security tokens as well. And the last part, communication testing. All the communication between IoT gateways, between central applications were not protected, were not encrypted. So this data could be by casual sniffers easily intercepted, analyzed, and then changed by more advanced users. To sum up, what is the value from this product security? What is the value of securing the industrial IoT infrastructure? So I would like to point here 3 points. The first one is software and hardware security, that we are protecting properly our devices, which we are delivering to our clients. Strengthening business processes, which makes life easier for the future improvement of our products. And also it shows that we are considering the needs of our customers seriously. And the third one is that we can be compliant with relevant standards and regulations. And to close up again with Tongu in our cheeks, we can say that this IoT is all about fridges, but don't take it seriously. It is not only about that. We should also consider security in here, in IoT, and IoT is not only the end-user devices which we are using on a daily basis. It is also a big part of the critical infrastructure, of security infrastructure, and it is all of our future and today world. Thank you very much for your attention.